So we're going to go on to finding the distances practice, and here are some of the points we want you to find the distance between. You should probably pause the video now and have a go. I've already had a go, and I made it a little bit messy, so I'm going to have another go at filming this and making it easier for you. Okay, so pause. Okay, so we're back from pausing, and here is our first 2 points, 0, 0, and 8, 10. So, what are we going to get out of this? Well, we know one point is 0, 0. And we know another point is 8, 10. Okay? So, to find our distance between them, first we have to find the horizontal distance, and that equals 8 minus 0. 8 minus 0, which equals 8. And our vertical distance, which is 10 minus the second number, minus the second number, 0, which is 10. So now we have our two distances. We just use Pythagoras. D squared equals 8 squared plus 10 squared. Or D squared equals 64 plus 100 equals 164. So therefore D equals the square root of 164. And you get some little fraction, but a square root of 164 is the most exact way to express it. Okay? Now we're going to go on to the second part. 4, 3, and minus 3, minus 4. So, note, I'm going to put the second number below, because it's actually below. And it doesn't really matter though, okay? You might think it matters, but the distance between this one and that is the same as the distance with that and that. So A and B is the same as B and A. So let's put these 2 points in for 3. And what do we get? Horizontal distance is 4 minus minus 3 is 7, or 4 plus 3. Our vertical distance is 3 minus minus 4, or 3 plus 4, and that's 7. So D squared equals 7 squared plus 7 squared, which equals 49 plus 49, which equals 98. Okay, so D equals the square root of 98. And we can try and simplify it. Yeah, so this is 49 times 2. And what's the square root of 49, guys? 7. So it is 7 squared times 2. And therefore we can take that 7 squared out and make it a 7 root 2. Okay? Good. This third one, distance between A and A plus 2 and 1 and 3 is simple. We can do the same exact procedure. Okay? Now I'm not going to put the points in. Maybe I will put the points in. This is 1, 3. We don't know where A is, but it doesn't matter. A is just some number. Let's just print it there. Okay? What's the horizontal distance? Well, this is 1 across. This is A across. Difference is A minus 1. This number minus that. What's the height? A plus 2 minus 3, which is, I need some little gap to do it. A plus 2 minus 3 equals A minus 1. Okay? So what is our distance here? D squared equals our horizontal distance, A minus 1 all squared plus A minus 1 all squared. D squared equals 2, A minus 1 squared. D equals square root of 2A minus 1, which equals A minus 1 squared. So now we can take that squared square root out, it becomes A minus 1 because they cancel each other, and we're left with root 2. Finally, I'm going to do the generic one, x1, y1, x2, y2. And this tells us the distance between any 2 points. So if I had this point over here, x1, y1, so a point over here, x2, y2, x2, y2. This will tell us the distance between them. So what's the difference in height? Difference in height is y2 minus y1. What's the difference in width? Distance is x2 minus x1. So our distance squared equals y2 minus y1 all squared plus x2 minus x1. x2 is on the wrong place. Squared. Okay, so distance equals the square root of that. y2 minus y1. So this is a nice formula to know, but it's much easier just to know each of the individual parts and how to do this. Okay, I'll leave it there. Cheers, guys.